Okay, good evening. My name is William Harris, and I'm delighted to welcome you here to Space Center Houston for our Thought Leaders series. The program tonight is The Future of Spaceflight. We're really excited to welcome you here for this program. We're just coming off an amazing period of celebrating the 50th anniversary of Apollo 11, and so it's really appropriate that we begin a conversation about where are we now and where are we going into the future. Through our Thought Leaders series, we engage space exploration leaders in stimulating discussion and provide you with an opportunity to participate in the conversation. Space Center Houston strives to create a community of problem solvers and fuel the STEM pathway to advance a science and engineering literate community and society. We are the official visitor center for NASA Johnson Space Center, a Smithsonian affiliate, and that enables us to bring to the public current and historic information on the space exploration and artifacts from the National Collection. The pre-program slides you've been seeing behind me highlight some of the many programs that we have underway currently here at Space Center Houston. We hope that you'll come back and participate in those and join as a member, and then you'll get a preview on those incredible programs that we'll be offering in the upcoming year. You can find more information at spacecenter.org. You'll also see on the screen later during the panel an opportunity to pose questions. This program tonight is being broadcasted on Facebook Live, and so we want to give our virtual audience an opportunity to ask questions. If you have a question, the instructions will be on the screen as to how to email those in to one of our crew members, and they will relay those questions to the moderator. So I'm delighted this evening to introduce the moderator for this panel, Dr. John Charles. Dr. Charles is our scientist in residence here at Space Center Houston. He has a very distinguished career of over 30 years at NASA Johnson Space Center, where he oversaw a number of fascinating research projects and under human health and performance, including Senator John Glenn's return to flight and also the twin study with Mark and Scott Kelly. So without further delay, please join me in welcoming Dr. John Charles.
Thank you very much, William. I appreciate the opportunity to be here tonight. Thank you for the opportunity to be part of this panel. And I really must say that when this panel was announced, I hoped I would be asked to be the moderator, because these are rock stars. This is the future of human spaceflight from NASA, as William mentioned. And as he mentioned, we have just recently celebrated the 50th anniversary of the first human spaceflight to the moon, the first human moon landing, Apollo 11. We all remember the excitement from 50 years ago, and I remember it very acutely as a 14-year-old watching TV. My parents let me stay up all night to watch everything, and it was an inspiration for my career and for the future that I hope to be able to be part of. Tonight you get to meet the people that will give us that future again. Tonight we will be talking about the upcoming NASA manned human spaceflight programs, especially the Orion program, which is the follow-on to the space shuttle in the mode of Apollo, and also the Gateway, the space station that will be orbiting around and near the moon that will enable exploration of the moon. So this is a chance to meet the people that will be taking us into the future, both to the moon and then again, then after that off to Mars. So with that as a brief introduction, what I'd like to do is introduce the panel members themselves. And you've already seen their pictures up above us, but I'll introduce them very briefly. The first is Mark Kirasich, and he is the program manager for NASA for the Orion spacecraft program. Mark, just stand up, please, and say hi. And he'll be the first speaker of the panel members. After him will come Dr. Mike Hawes. Mike is the vice president for Lockheed Martin, and he is the Lockheed Martin program manager for the Orion spacecraft. Then after Mike will come Lara Kearney, and she is the deputy program manager for the Gateway Space Station program. So this is the destination in orbit around the moon that the Orion capsule will be taking astronauts to and from. And I'd like to start the whole activity off this evening with a video that they've kindly allowed me to show, so I will see if I can make it work right now.
50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon. We are returning to the moon.
As a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we would discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go.
We go as the Artemis generation.
We go.
Thank you, John. Thank you, William, and good evening. I wanted to start by saying I had a very similar youth to John and a similar calling that drew me here down to the Johnson Space Center in Houston, except I'm not nearly as old as John. I was 9 years old on that July evening in 1969, so I'll let you do the math. But it has been a very exciting year, first of all with the 50th anniversary, and also with, it was just a couple months ago that this administration, this president, put his fingerprints on the future of human spaceflight. And Vice President Pence, and we'll talk a little bit about this later, and how both Orion and the Gateway play into it, announced a really challenging goal of putting the first woman and the next man on the moon within 5 years. So that has really focused our work. And this is a chart which illustrates Orion's flight plan, our manifest. And it's an interesting time to be in Orion. We're just finishing the phase that we call DDT&E, which stands for Design, Development, Test, and Evaluation. And it's how we get to the first flight of people on a new human spacecraft. And you can see from this we've planned 4 unmanned test flights. And I'll read from the bottom. PA1 stands for Pad Abort 1. EFT1 is Exploration Flight Test 1. AA2 is Ascent Abort 2. And then the series of Artemis flights, which are all aboard Orion, will be flown into orbit on top of the new Space Launch System. The first 3 of those we've completed, 2 tests of our abort system, and I'll show you some of those tonight. One abort test, which was in December 2014, and our next flight will be a flight that Orion travels back to the moon. It'll be for the first time that a spacecraft built for people has been sent to the moon since the end of the Apollo program. That's scheduled for just a little bit over a year from now. And after that, then we start flying people and we get into a cadence. So when Mike Hawes, my counterpart from Lockheed, and I talk to our team, we talk about finishing this design and development phase strongly and then getting into routine production and flight operations. So now a couple of pictures to show you that. First, this is what we have going on in the program today. For the last 2 years, we've had 5, we call them 5 major production and test campaigns going on. And right now what that means is, first of all, 3 lunar flight vehicles, Artemis 1, Artemis 2, and Artemis 3, all in various stages of manufacturing, test, and integration. And you'll see more of that in just a bit. Secondly, we just finished, a little bit over a month ago, on July 2nd, our second major test of our abort system, Ascent Abort 2. And third, when you're building a new spacecraft, you have to put it through a really rigorous, extensive series of tests called system qualification tests. And you'll see just a little bit of that here tonight. So I'll start with describing each one of these campaigns. And these are some photos of the hardware that we built for the Ascent Abort 2 flight test. Let me make sure this. On your left, and my left too, as I'm looking this way, it's a crew module test article. And on the right is our launch abort system. The launch abort system was designed as an emergency feature. When we built Orion, crew safety, the safety of our astronauts, was one of our top considerations. And this system is designed to protect the astronauts should anything happen during the most hazardous part of the flight, the ascent phase. So from when they climb into the capsule until they're safely into orbit. And what happens is the launch abort system is put on top of the crew module capsule. And should something happen, should an emergency happen to the rocket underneath, the launch abort system pulls the capsule away and pulls the crew away from whatever is happening. These are the actual flight articles. And one of the things we do in order to get ready for the abort test is we test all of the motors. I'm going to go back just a second. Does this have a pointer? We'll try it. Here we go. Our launch, this abort system, it has 3 motors. The big nozzles here, that's the abort motor. It's a 400,000-pound solid rocket motor that fires about 2.5 seconds. And when we did the pad abort test several years ago, with that amount of thrust, it accelerates the capsule from a standstill, from a launch pad standstill, to 500 miles per hour in just a little over 3 seconds. That's the motor that will pull the crew away if we have to abort. Right above that, you can see an additional set of 4 nozzles. That's the jettison motor. The jettison motor actually has to work every single flight because when you get into orbit, you have to pull the launch abort system off because the capsule has to be exposed to space. That has to be the most reliable motor. It works every flight. By the way, we really hope we never use that big abort motor with crew on board. And then at the very top, it's another solid rocket motor. It's a steering motor. It's our attitude control motor, and what it does is it steers the capsule during the abort phase. And I'm not sure if you're aware of that. Apollo had an abort system, but they did not have the technology in the days. It had a very simple pitch motor. And if you can imagine, if you're flying to orbit on a rocket and something happens underneath, there will be initial conditions, velocities imparted as you're getting away from it. And if the pitch motor points you in the direction you want to go, great. If not, it's not a very good day. The abort motor actually can steer through an abort, so our range of survivable abort conditions is much larger than any space vehicle ever before. So we'll show you a little bit about how this works. What we do, we test each one of the motors before we fire the system as an integrated system. And we have, for each motor, we have a series of 3 qualification tests, and I'll show you the video of each. The first is the jettison motor. It's a 40,000-pound motor that fires for a couple of seconds, and again, it's designed to pull the launch abort system off the capsule. That's the smaller of the motors. Now the big motor, 400,000 pounds, fires for about 2.5 seconds. And finally, this is the interesting steering motor, attitude control motor I mentioned. And you'll see how it operates as an integrated system, but you'll see this actually fires for about 27 seconds because it covers the entire abort and reorientation phase. It's a single motor, and the thrust it generates is constant, but a series of valves modulate the thrust in order to get the steering and the pointing that we want. So you can see a lot of work, a lot of development, a lot of testing goes into something before you're ready to demonstrate it as an integrated system. And you get to a day like today. Now this is our second abort test. I described our first test was from, we called it a pad abort test. It demonstrates if you're starting from a standstill. And when you talk about aborts during an ascent phase, there's really, if you have this range of conditions you might need to abort from, we call it corners of the box. One corner is when you're sitting on the launch pad. And the idea if you're sitting on the launch pad is you got to get far enough away, because when you deploy the parachutes and if the wind's blowing the wrong direction, you don't blow back into the fireball underneath you. So that's a pad abort case. And that's what we did in 2010. That was the 0 to 500 miles an hour in 3 seconds. Just this July, we did the other corner of the operational box. It was called an ascent abort test. And this is another really demanding condition. How many of you, when you were kids, or even if you're adults, it's okay to admit it, traveling down the highway with the car going 60 miles an hour, have stuck your hand out of the window and felt the air pressure? So you know what I'm talking about. Now imagine you're not going 60 miles an hour, but you're going 800 miles an hour, and you did the same thing. So that was the purpose of this test. At about the fastest speed when we're still going through the atmosphere, so we're not yet out of the atmosphere, it's a range that we call maximum dynamic pressure. So we're going 800 miles an hour, intense pressure on the vehicle. The abort system, the 400,000-pound motor, not only has to overcome that dynamic air pressure, but remember, it's a solid rocket motor underneath you trying to catch you. So it's a really hard abort case. What we had to do, since we didn't have the launch vehicle, a space launch system yet, we had to build our own. We had to build a space launch system simulator, if you will, and a really interesting story about, I would say, swords to plowshares, converting ex-military technology. The motor for this came from a Peacekeeper intercontinental strategic ballistic missile, actually on station in Wyoming for 2 years. During when we had the thaw, if you will, in our Cold War, the motor was excess, and we bought it, and we built this abort test booster. And here's what it looked like. And here you can see Orion getting stacked on top. And this was the launch vehicle the day prior to launch. And the next is the video of our test day.
T-minus 10. 5, 4, 3, 2, 1, ignition. We'll see our launch vehicle is carrying AA-2 launchable system.
So the launch vehicle is accelerating us to 800 miles per hour. It takes about 50 seconds. By the way, we didn't expect to go that straight up. The motor turned out to be a little bit hotter on the launch vehicle than we were expecting. We planned 55 seconds. We got to 800 miles an hour in 50 seconds. That's how hot the motor was. But you'll see here in just a second, you'll look at the top of the tower, you'll see the abort motors fire, and you'll see the capsule pulled away. Right any second now. There we go. And you can see it pull and accelerating the capsule away from the launch vehicle. Now we'll see a camera view from the rocket itself looking up, right there.
Pyros 1 and 2 discharge both sides.
So now as we're flying away, you're going to see the steering motor. What it's going to do, it's going to flip us over, because we have to flip the capsule over in order to get a very stable condition for the capsule to pop out. So there's the flip over, and now you're going to see the jettison motor fire. And the capsule pops out.
Pyros 3 and 4 discharge both sides.
So first, a really incredible test. Again, that was an abort under the most demanding ascent conditions that crews will ever see on Orion. And if there was a problem with a rocket on this day, the abort system would have saved the crew's life. So a really good day. By the way, we did not put parachutes on this. We intentionally did that in order to get the test accomplished as quickly as possible. So really good day down in Florida just a little over a month ago. Let's see. Thank you. Yeah. All right. Now to talk about the next major campaigns we have ongoing, I wanted to introduce my counterpart from Lockheed Martin, our prime contractor. NASA sets the requirements, and Lockheed Martin actually builds a spacecraft for us. My counterpart, Mike Hawes. Thanks, Mike.
Thank you, Mark. John, William, I appreciate being here. We're going to put Laura on the spot, I think, ultimately. I was 13, John, so folks can, and that translated into me actually showing up here at JSC in 1978, so just a little while ago. So I have the pleasure today of leading the industry team, which Lockheed Martin is the prime for Orion, but we have a vast team of subs and suppliers across the country, actually across the world. And so it's really exciting to be able to see this aspect of the program. So, okay? All right. So we want to talk about actually how the hardware comes together and what all the piece parts are. So this is the Artemis I crew module. This will fly in 2020 as an uncrewed flight out around the moon for on the order of 3 weeks. So this is really the test and the ring out of the Orion system in general. You can see right now on the sides there are covers on top of shuttle-style tiles. So for the sides of the spacecraft, the shuttle-style tiles are fine for the heat load, but on the bottom they're not. So the shiny bottom that you can see is actually the Mylar tape that's over a material that we call Avcoat. Avcoat was invented for the Apollo missions, and we have since reformulated it, and we're now actually constructing it into blocks similar to a shuttle tile that we actually then mount on top of a composite shell spacecraft that's mounted on top of a titanium frame. So a lot of techniques and capabilities that we didn't have in the Apollo era are really the ways that we're building Orion today. And then this is the service module. So the service module comes in a couple different pieces. The very top ring that you can see, we make. Suppliers across the country provide us parts. We put it all together. In Florida, we have taken over the high bay of the operations and checkout facility at KSC, and that is actually our factory. Now, below that big ring is something that's called the European Service Module. So NASA worked an arrangement between NASA and the European Space Agency that they would build the lower portion of the spacecraft, and that provides the propulsion. It provides the electrical power. You can actually see one of the arrays on here. It holds the water and the gases for breathing. So really everything that sustains the crew in the crew module while they're joined together on orbit. This picture is kind of an interesting setup. We have also been demonstrating some new innovative ways to test the spacecraft. So rather than move everything into a big acoustic chamber, in this case we have used a new technique that we call direct field acoustic testing. So those are speakers that are set up all around the spacecraft. We've done it for the crew module and for the service module, and then we just blast the spacecraft with all kinds of sound to demonstrate its capability to handle all of the acoustic loads of launch. And so rather than do everything in really large facilities across the country, we're actually able to do this right in the O&C high bay where we've assembled the spacecraft. The cone below is just a mating adapter. Below that, if you actually looked through that, you'd see the main engine of the European Service Module, and that's actually a leftover Space Shuttle Orbiter Maneuvering System engine. So we're repurposing on Orion the shuttle OMS engines and have been rebuilding those engines to be able to use for Orion. This is just a little clip to give you a sense of the scale of the service module. This is where we're moving it out of an assembly stand and we're moving it down the length of the operations and checkout facility. On the industry side, our industry partner that we work on the European Service Module is actually Airbus Space and Defense. It's an interesting world when you hop over to the industry side where we frequently joke and refer to each other as competimates. And so I have folks supporting Boeing, helping build the Space Launch System, and actually Lockheed Martin and Airbus Space and Defense are actually the two largest aerospace and defense companies on the planet, and having us work day in and day out together has been an interesting setup too, but it's actually gone very well. And so here we are getting stacked, and so the operations checkout building was actually built for the Apollo program, and that was where the Apollo crew and service modules were actually brought together and stacked and tested. So we're basically in the same location in the building that Apollo was stacked. We lowered the service module. We have lowered the crew module. You can see the film around the outside of that ring. That's really solely so that you can't see anything inside it. Otherwise, we would send you all to jail. The challenges of dealing with export control is a real challenge in the world that we have on Orion. But actually, usually that will be closed out on panels. And the pictures that we saw earlier showed white panels closing out that. But here, we're getting ready to stack the crew module. So we actually have to have those spaces open because we're going to go and we're going to attach the two with just 4 bolts. So 4 bolts and an umbilical that comes over the side that makes all those power, data, fluid connections are what holds the 2 pieces of the spacecraft together. Around those 4 bolts are pads of a quartz carbon impregnated material that's, you know, one of the more fascinating supplier stories that we have on Orion. Those pads are made by a company called Bally Ribbon Mills. They make military ribbons. And if you go in their plant, there are dozens of looms that are churning out military metal ribbons. And then about 2/3 of the way in, there are machines that are weaving composite carbon panels. And at the very end of the facility, there are 2 machines that weave a 3-dimensional block of quartz thread. And then we put carbon, soak carbon into that material, autoclave it, cut it out into discs, and that's what surrounds those bolts because they have to be able to take a shock force and they have to be able to also take the heat load. And in this picture, you can also see the shuttle tiles because we have one of the forward bay, or one of those covers off of the, what we call the back shell panel. So you can actually see the shuttle tile pattern. Same facility that we used for Space Shuttle, that tile facility at KSC actually forms and cuts those tiles for us on Orion. And here we had a really special day when you know, William was running ragged with the anniversary celebrations here. Much of the Orion team was at KSC because the Vice President chose to make his anniversary comments there in the ops and checkout building with Orion as the backdrop. And so we had our team there and the Vice President there. Buzz Aldrin was there with us. And in that discussion, the Vice President also announced that our crew module was complete. We're finished up, we're ready to go into final test. So we expect in about a month that that integrated stack is going to start its way towards NASA's Plumbrook Station in Sandusky, Ohio, for a full-up test, thermal test in the big thermal vac chamber in Plumbrook Station. And then it'll come back to Florida and literally be turned over to the ground team for stacking onto the Space Launch System. So big milestone for us, really, I think really demonstrates kind of the interest that this administration has shown in moving the human spaceflight program forward, as Mark had mentioned before. And we are building Artemis II. That was on one of Mark's campaigns. This is the Artemis II crew module. The big panels are manufactured across the country. They come together at the Michoud Assembly Facility outside of New Orleans. They're welded together there, and then it's delivered to KSC. This has actually been in work at KSC for about a year now. And so just the green structure is what shows up. Everything else, all of the silver pieces, we call them longerons and gussets and things, and those are all added there in Florida. So still a lot of work to do on Artemis II, but well in the way. And as soon as we get Artemis I out to Plumbrook, then we'll actually be going great guns on Artemis II. This is what the second European service module looks like. You had seen the service module all encased. This is what it looks like as it's being assembled. And just as we on the US have seen, we've had a great learning curve from having been through multiple builds. For the crew modules, we've actually built 5 crew modules. We had a ground test article, EFT-1. We built the structural test article that Mark talked about, that test campaign, and Artemis I at the same time. So we have had now a great learning curve experience, and we're seeing that our ESA colleagues are finding the same thing, and that this is moving along, you know, very smoothly. This is the bottom of the European service module. Those red-orange cages are over engines that we actually provide to the Europeans, and right in the middle where all those connections are is where the OMS engine would go. Mark talked about the test campaign. This is a test campaign. We're doing most of this testing out in our Lockheed Martin facilities outside of Denver. And this is a propulsion qualification module, which is a NASA ESA test going on at White Sands. Just this week, we had a great test. We had a great test firing earlier this week, of all of the engines on the European service module as part of its qualification. So another really big milestone for the program getting ready to fly. This is called the Orion Integrated Test Lab. This is out in our facility in Denver, and this is where we do hardware and software integration. So this is a simulated version of Orion. It has some of the actual flight-like components, and we test the flight software. Before we put flight software on the vehicle down at Florida, it goes through the ITIL here. And so we're doing the final tests to get ready to button that spacecraft up to get it down to Plumbrook. And there's a minimum set that we want to do before we actually send it off to Plumbrook. And this is Artemis 3. One of the things that Mark did was actually authorize us to go start buying what we call long lead parts. Typically, we think of that as electronic parts that are really exotic and take time to build. But we also learned as we were poking around in the system that large ingots of aluminum are also long lead parts. So this will become the barrel, which is that main cylindrical part of the body. So we bought the material. It's up with a company called Ingersoll up in Rockford, Illinois. And that's where it will actually be machined into that honeycomb style panel that you saw in the other pictures. And I think this is where I turn it over.
Just to bring it home. Thanks, Mike. As you can see, we're very lucky to have Lockheed Martin as our prime contractor. So now a little bit, again, getting back to what John said, talking about the future. It was just a couple of months ago that the Vice President announced his really bold goal to return Americans, first woman and the next man, to the surface of the moon by any means necessary within 5 years, 2024. So you can imagine how exciting that was for the people on our team, on the Orion team. So what did we do? What Orion's role, and now we're getting a little bit, and we'll transition to what Lara and the Gateway does. The architecture is different from Apollo. In the Apollo program, everything that we needed to land on the surface of the moon was brought to the moon with a single launch of the Saturn V launch vehicle. So the crew module, service module, the Orion equivalent, as well as the lunar lander. But then what happened is, at the end of the mission, you would throw the parts away. So this time, one of the goals of the Gateway is, first of all, is to make the program more sustainable. So we'll build the Gateway, which is a spaceport, a small space station in orbit around the moon, and we'll have the pieces that we need to go to the surface of the moon stationed at the Gateway. We'll need to bring gas with us back and forth, but we won't be throwing away the pieces with every flight. We'll be able to reuse them, more sustainable. Another thing Laura will talk about is the Gateway, given the orbit it's in. Apollo really, the parts of the moon that Apollo could really land on was very limited relative to the overall surface of the moon. And the Gateway, because of its orbit, it will allow us to reach almost any point on the surface. So that's the purpose. Orion's role then in the new architecture and the new goal is to be the spacecraft that takes people, pieces, equipment, and even Gateway elements from the Earth to the lunar orbit and dock them to the Gateway. And then after the lunar missions are complete, we'll take the people and the cargo and actually lunar samples back to the Earth. And one of the things, you know, people ask me because that's what happens when it takes years and a development effort spans several presidential administrations. One thing that's constant is we vote for new presidents because they offer change, right? So we brought in a new president. Sure enough, he changed our program. So people ask, well, what was the impact to Orion? And this is the great thing because, and I want you to watch closely, this was our plan before the vice president's announcement. And I'll show you in just a second. And again, watch the dates, watch the configurations. A couple months ago, this was our plan afterwards. You see what really changes the names of our missions. We used to be exploration missions, now we're Artemis missions. But that was really, in terms of our schedule, the Orion schedule, we are on track to support the President's challenge to us. You notice the dates, 2020, 2022, 2024. We are on schedule to do that. And the technical capabilities, everything we need of the spacecraft to take people and the cargo to the moon are built into the spacecraft, and we've developed through the series of development activities we just talked about. So Orion is ready to support this goal. There is one problem. Mike and I, we've bought a lot of shirts that say EM, so we have to, you know, we're going to put those on eBay. We're going to be buying Artemis shirts, but that was the impact. So that's the Orion role in the future of human spaceflight. So now I want to introduce the next speaker, Lara Kearney, who's the Deputy Program Manager of the Gateway Program, and we've talked a little bit about that, but I have to tell you, one of the reasons I feel really confident about Gateway being there in time is Laura's background. Her job immediately prior to becoming the Deputy Program Manager with the Gateway, she was the manager of the crew module working in Orion. So Mike showed you the articles, Artemis 1, Artemis 2. Laura actually was responsible for designing and building and delivering those vehicles. So, Laura?
Okay, so I guess Mark and Mike started the bidding with how old they were when Apollo landed. So I can say I was alive, but I was 7 months for the record. So they have a little bit on me here. So thanks, Mark, for mentioning. I did spend 7 years in Orion, and as you can tell from what they talked about, is an incredibly exciting time to be part of Orion because they're building hardware and they're testing hardware and they're flying hardware. So I got an opportunity to work this infant thing called Gateway, which is in its conceptual phase. So from here on out, there are no pictures of hardware to show you guys. So we will explain what Gateway is about, what we're doing, where we are in the process. But I want to show you a really quick video. Again, it's mostly Orion, but...
From the Kennedy Space Center in Florida at T-minus 3 hours and holding.
It is great to be in Florida today. The rocket is ready to go fly. And the team is ready to go fly.
Not only for expanded knowledge of the universe, but for the improvements you have contributed to on Earth. Have an excellent vision and Godspeed.
Cruise ingress and work at this time.
Do that. Flight crew, OTC, close and lock your visors, and initiate OTC flow.
T-minus 10, 9, 8, 7, 6. All engines up and burning. 2, 1, 0, and liftoff.
Okay, so I like to think of it now as just being on the other side of the hatch, right? Waiting for Orion to come visit, so. Okay, so you'll see these words. Basically, it says forward to the moon, and Mark talked about it a little bit. You'll hear our administrator, Jim Bridenstine, use this terminology a lot, forward to the moon instead of back to the moon. We're trying to go this time in a very, very different way. Our environment is very different. We have a lot of commercial partners and international partners out there that are able to help us with this mission. We're now wanting to go, and Mark used the word sustainable way. I think of Apollo more of like a point solution. They went to a specific destination, they did their exploration around that destination, and they came home. Our intent this time is to go and to stay on board Gateway, to build a lunar surface infrastructure, so that we can learn how to work and live on the moon and eventually enable us to go on to Mars. So like Mark mentioned, there's a lot of things about the Gateway that are kind of pivotal to making that a sustainable approach going forward. So when you hear sustainability, what does that mean? We've learned over time how to develop these programs under what we call fiscal realism. I don't know, if you guys hear these numbers, but the NASA budget today is, half a penny of every tax dollar goes to NASA, and of that, only a fraction goes into human spaceflight, compared to 5%-ish that went to the Apollo program. So relatively, we're working with a much smaller budget, which means we can't do big programs all at once. We have to phase things out over time. So we've learned how to establish things and build on them over time and not come with these, big, massive programs that require everything be delivered all at the same time. I mentioned commercial and international partners. Through the NASA commercial cargo and crew programs, you see Boeing and SpaceX, Sierra Nevada. Those companies are all out there now helping us take care of our space station, get cargo up to space station, and soon, hopefully within the next year, get crew up to space station. So we now have partners that are available to us that can help us going forward, that have a vested interest in investing their own dollars and making it happen. Same thing from an international perspective. We've learned so much with the International Space Station over the last 20 years on what international partnerships can bring as well. So for Gateway going forward, it's really about NASA being in a leadership role, trying to provide that infrastructure that commercial and international partners can come play in, and stitching it all together into a program that works. Let's see, architecture, openness, resilience. Like Mark mentioned, we see administration changes. They have different ideas on what they want to do, what their goals are. So we want to make sure we set ourselves up for a place where we don't see a gap like we have seen before with the shuttle retirement to the time we get Orion and our commercial crew flying again. So we want to make sure we've got this program in a place where we can get people on orbit and we can sustain them over time. So why Gateway? We get this question a lot. Yes, we absolutely could go back to the moon without a Gateway. But again, our vision for the Gateway is an aggregation point for the lunar components that come up. So when the lander components come up, we can aggregate them at the Gateway. We can bring what we're calling tankers or refuelers up to the Gateway. We can actually refuel those landing components, and then we can make multiple sortie missions to the lunar surface on those lander components without basically disposing of them every time like we did in Apollo. It also provides some redundancy and some safety aspects to the system. If they've got a problem, say on the ascent element or any of the lunar components, they can actually abort to the Gateway where they would be safe until they can get home on Orion. So it again starts to provide more of an infrastructure. We've actually created what we're calling interoperability specifications, and it says anybody that wants to come to the Gateway, this is what you need to do to be able to get there. We need you to interface with us in these kinds of ways for thermal, for communications, for software, all of those kinds of things. If we can write them in a specification that anybody can meet, that means multiple commercial partners, multiple international partners can all be flying to the gateway, and we can start to build that infrastructure up over time. We also know that we're not going to go straight to Mars. We need to be able to build infrastructure in orbit so that we can get onto Mars, and the gateway is a place where we can aggregate those Mars elements to go for a Martian mission as well. So this is it's conceptual on what the gateway, basically capabilities and components are. We will have a power and propulsion element that allows us to stay in the orbit around the moon. It also provides our communication capability to the lunar surface and back to Earth. It'll have habitable volumes where the crews can work and live. We'll have docking ports where we can bring logistics modules up. They'll be bringing consumables for the crew, but also consumables for the spacecraft. We'll also have docking ports for landing elements. And then you see, of course, Orion coming in and docking on our axial end there. We'd like to not really say space station around the moon. Space station today, you might hear in terms of the size of a football field, will be about 1/10 of that size, so we're going to be significantly smaller. And where the space station is inhabited 24/7, 365, the gateway will only be inhabited when Orion and the crew are there. So we're going to start off with crews being on board for about 30 days at a time, and then extend over time as we build up habitation capability. So it'll be a little bit different where we'll actually have the platform orbiting around the moon, and we're going to have to be able to operate that autonomously from the ground. The intent is to still get some scientific research done while it's uninhabited, and then the crew will come up and be there for 30 days or so during the lunar sortie mission. You see a little bit of a picture there on the right-hand side on the orbit. Mark mentioned that we are in what is called a near rectilinear halo orbit. That is a family of orbits that is kind of balanced in a sweet spot between the Earth and the moon's gravity fields. And because it's so nicely balanced, it is an orbit that is easy for spacecraft to get in and out of, and it's very stable for the gateway. So all that translates into minimal propulsion and fuel loss. So because we don't need the fuel, we can use that mass for other things. So we like that orbit because, again, it's very stable, doesn't take a lot of prop, but it's also in plane with the Earth so that as we're revolving around the moon, we are constantly, we see the Earth and we can provide constant communication from the lunar surface back to the Earth. So you don't have that loss of signal that you have if you were in equatorial kind of orbit. As Mark mentioned too, this orbit, because the gateway actually has its own propulsion capability, we can actually change orbits, which allows us access to basically the whole lunar surface. So where Apollo was limited to only going to certain point destinations, we can have a suite anywhere around we want around the moon to be able to explore and send the crew. Of course, you may know from the 2024 announcement that the first place we're going to go to is the lunar South Pole. That's, of course, of a lot of interest because of the potential for water there and what we can use that for both habitation and for fuel for vehicles. So again, we're an infant program. We kind of stood up in the February timeframe when my boss and I kind of took over for the program, and we got the 2024 announcement in March. So we were a month old when we got the 2024 announcement, and it didn't change our plans all that much either, but what it did do is make us focus on what is absolutely necessary to support a lunar mission in 2024, because we obviously have a lot of catching up to do. So we have termed that Phase 1, Phase 2. Our Phase 1 is simply the power propulsion module that will, again, keep us in orbit, a very minimum habitation. It's pretty much a pressure shell, and we are going to live off of Orion's life support systems for those first few missions of 30 days or so. And then the logistics module brings up the consumables, and then the lander comes in. And so it's just those few elements that we need to support the 2024 mandate. Once we get past 2024, we can start adding the other elements and build out the remainder of the infrastructure. And that's really where the international partners start to come in. We're expecting them to bring in an international habitat, which is going to allow us to stay longer. The Canadians are going to bring in a robotic arm similar to the one on Space Station. We have our friends from the Japanese Space Agency also providing some hardware and potentially some logistics transfer capability. And then we're in the process of determining how we will eventually get an airlock up there so that we can do spacewalks. So phase one, just a little bit of a status on where we are. Again, mentioned we've got some catching up to do. So power and propulsion element is the first element up. It's intended to launch in 2022. That's sporty for spaceflight hardware, but this has been a really unique acquisition for us. We just awarded it to a company called Maxar Technologies in June. And unlike a typical NASA procurement where we levy literally hundreds of requirements on a contractor, right, poor Mike, this one is completely different. So we, the people of the world, have space satellites orbiting above us all the time on these power buses. It's the things that are up there powering and communicating with our cell phones and all our GPSs and our cable television and everything else. So we said, okay, let's take advantage of what industry already has up there that are proven to be reliable. They're up there for 10 to 15 years. Let's just go out and buy one of those and see what it can do to support the gateway. So it has allowed us to really speed up the acquisition process and bring the cost way down and have a highly reliable system because they're flying so many of them in the commercial spaceflight industry. So that, like I say, was just awarded in June, and it is the first element that is up in 2024. Right after that is our habitation and logistics outpost. We named it that because we like the term HALO. We think that's cool. We just awarded it as well about 2 weeks ago to Northrop Grumman. And again, it's going to be just basically a structure with the two radial docking ports on it that will allow the lander and the logistics modules to come in. And like I say, live off of the Orion life support system. So the reason we did that is because we knew it was going to be a stretch to get a full life support system up there by 2024. So we're working with Orion to make sure we can share those capabilities. So again, it's a 2023 launch. And then following right after that is our logistics element, and we are modeling it after the commercial cargo services that are supporting the International Space Station. So again, through commercial partners, we have flights going up more often than most of us recognize, 6, 7, 8 times a year to the International Space Station. So these commercial companies know how to get cargo into low Earth orbit. We're going to now stretch them a little bit and see if we can't get them to get cargo to us out around the moon. So that one has a request for proposal going out here in mid-August, and our intent is to get it awarded by December. So not bad. From the 2024 announcement in March to December, we'll have all 3 of the major elements we need for the 2024 mission on contract and ready to go. So phase 2, again, already really talked about this. This is just where then we're going to extend our capability on orbit. We'll be able to stay a little longer. We bring in our international partners, and this is where we really start to learn how to live and work around a body that is in deep space. And that's where we start to also learn how to be the stepping point onto our future Mars missions. And that is all I have. So I will hand it back over to Dr. Charles.
They had to nudge me. I was busy taking notes because this is top quality information we're getting here. I'd like to ask the panel to come on up and join me at these chairs, and we'll do a little bit of a discussion. If you can figure out how to sit in the chairs, then yeah. Everybody's got a microphone. Take your microphones and hold them right next to your How about now? All right. Perfect. I can be taught. So this is our chance to let you ask questions. So you see the address there for the emails. It says Thought Leader. Is it thoughtleader at spacecenter.org? Thought Leader 1, right? At spacecenter.org. Please send any questions you have via email to that address. My friend Kimberly Lobet here in the front will be collecting your questions, and if the PayPal account is valid, she will pass your question on then to us. So while we are accumulating questions, I've got one or two to ask. I'd like to ask both Mark and Mike maybe to talk just a second longer about Orion. Orion bears obvious similarities to the Apollo spacecraft. Mike Griffin once upon a time described it as Apollo on steroids or Apollo 2.0, but it obviously is the 21st century version of Apollo. And maybe you can describe a little bit of what's different about Orion compared to the Apollo command module that we have on display here at Space Center Houston. And is it reusable? If you're building them by craftsmen, and it looks like it takes a year or so to build a single spacecraft, will you be able to get more flights out of it than just one?
Sure. John, let me start, and I'll say, yeah, if you do look from the outside, Orion looks very similar to Apollo. We're a bit larger. Our diameter is a 5-meter spacecraft. Apollo was 3.9-meter spacecraft, so we're larger, but the shape is almost identical. And the reason it is was very early on when we did our what we call phase A studies, we studied shapes of spacecraft and what spacecraft will be good coming back with lunar return velocities and entering the atmosphere. What was the best way to fly through the atmosphere? What was the best way to control energy, that sort of thing. And one of the things we found early on was that the Apollo engineers, even though they didn't have nearly the tools that we have today, computer models, computation, fluid dynamics, but they had really done a good job in terms of selecting a shape that was good for this sort of mission. So we selected the same shape as Apollo early on. Now past that, if you pull back the skin, like we showed a few photos, you're going to find a lot of differences between Apollo and Orion, and maybe that's where I'll ask Mike to talk about that.
Okay. Is mine on? How about now? Yeah. All right. There was a switch. You tried to. So first off, I'll tackle the question, is it reusable? Yes. Orion is designed to be reusable, and we have that factored in a couple different ways. But let me talk kind of about the technology of building. I will admit, I went to college with a slide rule. Nobody that works for me even knows what that is. So, everything today is digitally designed, and it flows through the entire system until you get to literally the milling machine that's taking the big hunks of aluminum. No, technically we're taking the little chips of aluminum out at a time to make those shapes. So the way that we design, the way that we manufacture is very different from what the Apollo team had to work with. We also are using new materials. We're using composites throughout the crew and service module in many different ways. We're also using augmented reality in terms of actually assembling pieces of the spacecraft. And so today's technologies based on yesterday's physics and shape, which are absolutely valid for the mission that we have. Now, we look at reusability in a couple different ways. We look at it in terms of what we've phrased as light and heavy. If we're not going to reuse that green pressure vessel, we're going to rip everything out of it and put it in the next one. If one of the areas where we still have some analysis and tests to do is there's a lot of hardware that's underneath those tile-covered panels, but outside of that big green cylinder. It's going to have saltwater exposure. And so one of the things we have to do is demonstrate that we can actually get the Orion system back, wash it off, treat it, and get it back into flow such that we don't have an issue with the saltwater effects on the spacecraft.
We didn't really try to do that for EFT1. In fact, we kind of let it sit over the Christmas holidays, and we got back to it and said, oh my, there's a whole bunch of water here. So there's a big piece of that. And one of the things that's interesting from my standpoint from Lockheed Martin, we've also reached out to like the F-35 team and the Sikorsky helicopter team to understand how they collect data and factor things on airframe lifetime that we can hopefully use in our own instrumentation for life of the pressure vessel.
Very good. Kimberly, how are you doing on questions? Very good. Well, I had a philosophical question I was going to ask Laura, but instead of that, let's see if we can get some questions from the audience. And note the address. I garbled it before, but it is actually thoughtleaders@spacecenter.org.
All right. First question I've got here is, will the lunar gateway be visible by the naked eye, telescope, or binoculars as it orbits the moon?
Likely not.
One of the things I did, talking to John, Mike, back to July 1969, was on an evening when I was a 9-year-old at one of the commercial breaks, I thought I could see Buzz and Neil, and I ran out to the street, and I looked up, and I couldn't see Neil and Buzz back then, so I don't know that we'll be able to see the lander either, the gateway.
How adaptable is the Orion design since it has different missions to accomplish?
Yeah, I think I demonstrated something that, we spent a lot of time early on. We took a little bit longer going through Phase A and Phase B, getting to our preliminary design review, which we call PDR, getting through our CDR, intentionally design in flexibility. And it served us well because we've had to survive some changes. And I showed you today when our mission changed, and by the way, that was about our third or fourth mission change since we started the program. When our mission changed just a couple of months ago, absolutely nothing about our technical baseline changed at all. We didn't have to change a thing to support the Lunar 2024 plan.
Will Orion astronauts perform EVAs?
Right now, Orion does not have the capability to send, let me say it differently. The basic capability is there. We have not augmented Orion ability to do Orion-based spacewalks. The idea was, both in our previous mission and now with the Gateway, that the people on board Orion will go into the Gateway, and any spacewalks will either be Gateway-based or lunar lander-based.
Can you say more about the South Pole lunar landing and why the Shackleton crater region is being considered as an important area?
So I've spent a fair amount of time with the lunar science community over the last few years. And when you think back, we did not find water in any of the lunar samples from Apollo. Every spacecraft that we have sent to the moon over the last 10 years has found evidence of water. 2 instruments on an Indian Chandrayaan-1 spacecraft, the L-Cross spacecraft that flew with the Lunar Reconnaissance Orbiter, and LRO itself have all found indications of water in lots of places of the moon. So that has changed the whole dynamic of looking at the moon, is the ability to get to water. One of the theories is that a lot of water would be bound as ice in shadowed craters. And so the South Pole Aitken Basin has the advantage of large shadowed crater, but also nearly totally sunlit peaks around that crater. So you have an ability to have full sunshine for all your systems, but you have very likely water deposits right there in the neighborhood.
Excellent. The crew is going to be spending 30 days on the moon. So what are some of the main activities they're going to be doing?
Well, let me also clarify that the crews at this point in time would not be on the surface for 30 days. So it would be a full 30-day mission. And as the timeline plays out, they would probably be on the surface anywhere from 5 to 7 days. But during that time, they, will be doing just, normal exploring, geological exploring, making sure the spacecraft and the systems are all in good shape, eventually building up infrastructure on the surface of the moon as other elements are being brought by, say, commercial providers down to the surface.
I've had a few questions that want to know a little bit more about the lander that's going to be used in conjunction with Gateway.
So let's see, I can tell you what I know about the lander program. It is, if I'm young, lander is even younger, right? So they are just getting started. The lander program is also trying to utilize more of a, quote, commercial model for how we want to procure lunar services. So the team is currently basically putting out a statement of objectives that will go out to industry, and we're looking for industry to help us understand what the best way is to get to the moon, basically from an end-to-end service. So how would a company launch, get to the Gateway dock, and then get to the lunar surface? So that's all actually in the beginnings of the acquisition phase right now, and I believe they intend to award those in the fall sometime.
Yeah, that's the planning. I have another title. In addition to Orion Program Manager, I'm also Vice President of Human Space Exploration for Orion, so all of our ideas about landers and things are what I get to do at the night when I'm done with Mark all during the day. When you looked at the pictures that Laura had up there, you see kind of the NASA converged version of a lander, because they're certainly not going to show you my version or a Boeing version or a Blue Moon version. But you see it's actually three pieces. The bottom piece, you can see the legs appear to be in the middle. That's because that bottom piece is actually a transfer vehicle or a tug that's going to get you from the Gateway down closer to the lunar surface. And then the descent stage has the legs. It's going to take you there. And early on, I think most all of us believe that we'll start with two separate elements. A descent stage that actually stays on the surface, but an ascent stage that is actually reusable, and we'll go back up to the Gateway.
Mike, by the way, when this is over, we got to talk about, I didn't realize you had free time in the evenings.
I still take your calls.
When the Gateway is unoccupied, will there be robotic astronauts like the Robonaut 2 taking care of the systems?
We definitely are looking at having what we call IVA, or intravehicular robotic capability, while it's not manned. Probably not starting out with like a Robonaut type of thing, but more of a robotic arm, like a small robotic arm that potentially runs on rails, say, throughout the internal section of the vehicle. So yeah, the intent is definitely to make sure we're taking advantage of the 11 months out of the year that the crew's not there, to make sure we're getting scientific utilization back.
What are some of the greatest lessons learned from Apollo that you wish to apply to Artemis?
We've I wouldn't say wish, I'd say we have. One of the things we did at the earliest stages of Orion, we invited, when we started, there were many Apollo veterans around. And actually, we met a few here right before the session tonight. So we invited many of the people who had worked Apollo to participate in the Orion program early on. And we learned a lot of things from them. I talked about the shape. One of the things, we had the Apollo program manager, Aaron Cohn, who eventually became the director of the Johnson Space Center. When I first came into the program, we had him come to talk to us. And one of the truest things that I ever learned was, we asked Aaron what was one of his biggest challenges, and he said mass, number 1, 2, and 3, and that means weight. And that was really true early on when you're designing a spacecraft that has to go all the way to the moon and back. The big problem is it's one thing to design it, it's another thing to be able to push it. So you not only have to design the systems, but they have to be very lightweight. So the weight, the shape, the materials. Mike gave you some examples of materials that were developed for the program that we have improved along the way. So I would say the Apollo fabric, another one of my favorite stories is switches. If you ever, and there's an Apollo capsule right here in the Space Center Houston, and I'd invite you to look into the window on your way out, you will see floor to ceiling the entire spacecraft covered with switches. Well, today, with computer technology, with display technology, the primary way the crew interacts with the Orion's vehicles is almost like your iPhone. It's via a very intuitive touch screen, where instead of having switches with very archaic names, everything's visually displayed and it's very easy to manipulate. But the people that flew on Apollo said, we don't trust computers, and certain functions are so important that we think you should provide direct crew input to end effector connectivity. So we named these switches the Tom Stafford switches. General Stafford flew on Apollo, and he was one of the gentlemen that advised us early on. So we have a series of switches. So really the lessons learned of Apollo are woven throughout our design.
Excellent. Yeah, go for it.
I know I'm not one of the panelists, but speaking from the scientific perspective, which is what I'm coming from, I think you already heard one of the important lessons learned from Apollo when Laura mentioned that the first landing will be about 5 or 6 days on the moon. The longest Apollo landing was for 3 days, and the astronauts, I think, uniformly complained about the time compression and the fact that there was so much more to do during their exploration of the lunar surface. And those were the dull, boring equatorial sites. If they land at the South Pole with the possibility of water, ice, and other volatiles perhaps being trapped in those perpetually shaded craters, having more time, like double the amount of time for the first landing mission, will be an important lesson learned from Apollo.
All right, and I'm going to do one last question. Can you talk a little bit about what we're going to learn from Orion and Gateway that's going to get us to Mars, and what that time frame might be?
I bet we each have some perspectives. Yeah. Why don't we each offer it? Yeah. And, you know, I will tell you the thing that I am most excited about, and you've heard it over and over and over tonight. And let's see if you get this. John told you about it, Mike told you about it, I told you about it, Laura told you about it. When we explore, I guarantee you when the first time we send Orion back to the moon, just a little over a year from now, we are going to excite a whole new generation of young people. And they're going to be excited to work hard, to study hard, to get interested in math and science. And some of these people will be like the four of us, and they'll end up down here in Houston in 20 years. Other people, they'll go into medical school. They'll go advance the electronics industry, the software industry. But really, I believe Apollo really motivated our generation and really had a great deal to do with the advancements in improving life here on Earth. And I think this program that we're working on is going to have the same impact to the next generation. I think that's going to be one of the biggest things.
So there's a couple aspects that I have, and one really touches in John's area in terms of the science. And I'm really bad, John. I never can remember who actually plotted it out. I always misquote. But one of the lunar geologists plotted all of the Apollo traverses on the scale of the National Mall in Washington, D.C. That's about what humans have explored on the moon. You get a little bit of Union Station and a little bit of Arlington, and that's it. So this whole been there, done that idea that we really understand the moon is crazy. And so like John said, going to the South Pole, going anywhere on the far side of the moon is just incredibly rich in scientific value. And so I think that is what I really see as being the benefit. And then ultimately, Laura's point about the aggregation point, our whole space economy has changed so much. So the idea that the Gateway gives us a place to meet from a lot of different sources and different countries and different launch vehicles allows us also to do things that we can barely conceive of in terms of our exploration of the moon.
Yep, for me, it's about, again, learning how to live and work and have spacecraft that survive a long way away. I mean, and the International Space Station, again, is incredible. It's been flying so long, we have people up there, but they can also get home in an hour and a half, basically. At the moon, it's going to take you 3 to 5 days to get home. Mars, it's going to take you months to get home. And so being around the moon and being there for a long time helps us learn how to build spacecraft that are highly reliable, that are more autonomous. We need our spacecraft and our crews learning to work more autonomously, not with a mission control that is sitting down here monitoring them literally 24 hours a day. So just the reliability of the spacecraft and the ability for the crews to be able to work on their own. I think we can really learn a lot on the surface of the moon before we take that risk going on to Mars.
And with that, I think it's time to wrap up our program for this evening. Thank you very much to the panel for a stellar presentation this evening. I'm so pleased at what we've been able to get across here tonight. And we have a few final comments from William Harris.
Thank you. That was absolutely fascinating. Thank you all so much for coming out this evening and sharing your expertise and experience and bringing us up to date on the latest on what's going on and returning humans to the moon and preparing to go beyond. So if you enjoyed the program this evening, please go to our website, sign up to our mailing list to become a member at Space Center Houston, and we look forward to welcoming you at a future program. Have a safe rest of the evening.